Hi there. My name is Giancarlo Frizzetti, and today I want to demonstrate the use of a Web 2 tool for mathematics that I like to use from time to time in my classroom. It's called Symbolab. Parts of it are behind a paywall. I'll talk a little bit about that later, but much of it is accessible for free. You don't necessarily have to create an account, but I have done so. In order to do that, you just click Join. You can join with Office 365, which would likely be through your school. You can join using Facebook, or you could just put in your email. I just used my Gmail and join that way. So I'll just click Sign In here real quick, and then I'll go through a demo of some of the tasks that Symbolab can help your students understand mathematics. The first example I want to go over, it can certainly factor quadratics. That's always a problem for students. So here's the example, x squared minus 7x plus 12. And I can just type it in the box, hit go, and give it a few moments, and it'll give you the factorization by grouping, gives you all the steps, allows the students to see the process that goes on. You can click step by step if you, see that's behind the paywall, so can't use that, but the basics of it are here. It shows you how to factor by groups. Another example is using the quadratic formula. If you wanted to type in any sort of a quadratic, I'll just pick a random one here, such as 2x squared minus 5x plus 34 equals 0. And it will show you the quadratic formula, and it will use that in solving the problem and putting the coefficients a, b, and c, grinding through the math, and getting the two solutions, which in this case are both imaginary. It can also handle higher order polynomials. Here's an example of that: x cubed minus 10x squared plus 13x equals 0. If I hit go, it's going to show how you can factor this cubic equation, and then get all the solutions by first factoring, and then basically uses the quadratic formula and to solve. Once it's broken it down to a quadratic, and there it shows how you use the quadratic formula to get the other two answers out. Geometry, you can use it for geometry. I know log cosines is a concept that a lot of students struggle with. So if you go to geometry and then hit triangles and then log cosines, if, say, they're given a triangle where they're trying to find one of the angles here in the triangle, but yet they know all the sides, let's say you want to find angle gamma here, and then if I enter, say, the sides happen to be where A was 18 and B was 8 and C was 24, and it will go through showing how you use the law of cosines to solve for the angles of the triangle. In this case, angle gamma would be 130 after you've rearranged the formula for law of cosines, which is demonstrated right here. And then you've rearranged it, you've input A, B, and C, taken the inverse cosine, and gotten the degree measurement of angle gamma and triangle. Trig identities, that's another area that students struggle with a lot. If you go to trigonometry, and then you can go to proving identities, and here's one that's a little bit tricky to prove if you were to do it by hand. At the very least, students would be able to perhaps use this to check their answers, or you could have them perhaps create some assignments with more difficult trig identities to show them how they would go proving those. Here's an example. Tangent squared x minus sine squared x equaling tangent squared x times sine squared x. And the software will actually, the website will actually show you how you go through step by step improving that trig identity. So that's kind of a really neat feature of Symbolab. From calculus, I'll give you an example from that. If you remember, if you know any calculus, you know that the critical points of any function are where it changes curvature. So it goes from either increasing to decreasing or decreasing to increasing. If you were to look at a graph of the following function, first let me click on calculus, and here we're going to select critical points, and there we're going to, I mean to say extreme points, and then I'm going to enter my function, which is x cubed minus 2x squared plus x plus 2. And it will go through the process of, a fairly lengthy process here, of checking signs. It'll take your first derivative and it'll check the sign of the derivative, where the sign of the first derivative changes from negative to positive or positive to negative. That's where you're going to have either a local maximum or a local minimum. So the Symbolab will go through that whole process, take the derivative, first derivative, check the signs by checking the point either side of that it needs to check. And it will give you the local maximum, local minimum of the function. One of the nice things that it also has to go with that is that you can click on a graphing calculator and showing there's a maximum at 1/3 and minimum at 1. You can use the built-in graphing calculator, and you can then proceed to check that result and see if it visually fits what the software gives you. So having this built-in graphing calculator is very nice. Here I'll show what I'm talking about. So if you go to x cubed, if you enter x cubed minus 2x squared plus x plus 2, and you can definitely see there is indeed a local maximum at 1/3 and a local minimum at 1. So they can immediately go straight to the graphing calculator and visualize what all the calculus work they did to find the critical points, turning points, I mean to say, of the function r. Another example I would really like to show is that you can even visually look at derivatives. You can say, if I'm going to take the first derivative, say of this function, what does the resulting graph look like? And so if I'm to do that, it allows you to copy this and paste it in here. And then there you are, and the students can visualize, okay, I see. So the rate of change of a cubic function of any point happens to be a quadratic function, and they can visualize those things overlaid over each other. The last, perhaps, area I want to show about Symbolab in terms of mathematics is where it can also do things that require more, tedious calculations, such as in statistics. So if I go back to Symbolab, that, and click on statistics, let me try to find out where I was going to show that at. Let's see, solutions. Here we are. Sorry about that. It took me a minute to get to that. Statistics. And then say if you wanted to find upper quartile of a range of test scores, you're able to do that. Just select upper quartile, and you would just enter the test scores, and you can use them randomly, and the Symbolab will do all the rest of the work for you. These are some test scores for a recent test that I administered. '93, '97. And if I hit go, it will give me the upper quartile of those scores. And it'll basically show the steps of calculating them. If you click Show Steps. And so this rarely lengthy, tedious calculation is done for you. And so it reduces the difficulty for students who struggle with some of these things. Or it can give them an additional way of looking at an example and enhancing their ability to practice the concepts you're trying to teach them in class. There is another feature called groups, the last thing I want to talk about. And you can create groups in Symbolab, and you can have discussion boards where you post questions and post examples out of Symbolab. So that's a neat additional feature that it has. I think it tends to be more enhanced if you pay. It's behind the paywall, which is $19.95 per year, I think. In cases, perhaps in the future, where I have maybe more advanced math classes where the students would be more into perhaps getting involved in spending the extra time to learn the site, which can be a little tricky. This is something definitely I might be willing to pay for and use in the future. Well, I hope this introduction you found useful and for an example of a contemporary Web 2.0 tool called Symbolab, and I hope you found it informative and useful. Thank you. Have a good day.